Today's lesson is solving two-step equations, lesson 2.9. So the basic questions you're going to be asking yourself are how do we use the inverse operations to solve two-step equations, and does order matter when solving the two-step equations? You just learned how to solve the one-step equations, and I know you're probably thinking, what? But relax. You'll use what you already know to solve the two-step equations. So to find a solution to an equation, remember we isolate the variable. What that means is we get the variable on one side of the equal sign by itself. We use inverse operations to get rid of the other numbers, or in other words, we perform operations that will eliminate or cancel the other numbers from the expression. So to eliminate a constant, we'll use addition or subtraction, depending on what the inverse operation is. And to eliminate a coefficient, we'll use multiplication or division. When an equation has both a constant and a coefficient, that's a two-step equation, and it'll take 2 steps to solve it. So let's see what we're going to do first. For step 1, you will be either adding or subtracting. So we're always going to be using the inverse operation of whatever's happening on the same side of the variable. This is different or reverse of what we do when we're solving for order of operations. So sometimes we're not used to using the addition subtraction to solve first, but we have to undo it in this way. It'll make it much simpler to solve because lots of errors are made when students try undoing the multiplication or division first. So step 2 will be to undo the multiplication or division by using the inverse operation. So let's try it. In 8x plus 5 equals 61, we're going to look at the variable. It's on the left. It's being multiplied by 8 and added by 5. So we'll undo the addition first. We need to subtract minus 5 on both sides. This is how you show your work on both sides of the equation. So we bring down what's left on the left, because plus 5 minus 5 is equal to 0. We've eliminated the constant, and we get 8x is equal to 56. Step 2, we're left with multiplication. So we undo multiplication with division. So we divide both sides by 8. Let's try another one. 3a minus 8 is equal to 4. So we're undoing subtraction. We need to add 8 to both sides. We'll get 3a is equal to 12. And now step 2, we undo multiplication using division, and we get a is equal to 4. In this case, z is being divided by 6, then added by 2. That whole thing will equal 26. So we'll subtract 2 from both sides, bring down what looks like the fraction with the variable, and carry that over to step 2, which will be undoing division with multiplication, so that we'll get z is equal to 144. You can always check your work by going back to the original problem. In this case, we have m divided by 5, and that's negative minus 10 equal to 15. So again, undo the subtracting 10 by adding 10 to both sides. We're left with a negative m divided by 5 equal to 25. And then to undo dividing by 5, right? Remember that a negative m over 5, and you're used to seeing it like this. We did this yesterday, so it could also be written as a negative 1/5 of m, so the original problem that was minus 10 equal to 15, okay? So we already did the add 10 step, and if you bring down this negative 1/5 of m, we've learned that multiplying by the reciprocal, which in this case would be multiplying by 5 over 1, okay, on both sides. Negative 5 over 1. Make sure that that's negative. So you can see same thing. M is equal to 125. All right? So having it written like that or like that are actually the exact same thing and in essence are solved the same way.